Hello everyone, welcome to Stanford Union class. We'll study cluster sampling, in particular the single stage cluster sampling. So far we have considered element sampling where we select elements directly in the sampling. Now cluster sampling will be studied, and in the cluster sampling we select a group of elements called the cluster. So the sampling unit is cluster and not equal to element. So the first type of cluster sampling is it is simplest one, single stage equal probability sampling, where we we select simple sample clusters and observe all elements. In two-stage sampling, we select sampling of clusters, stage 1, and then in stage 2 we have another sample of elements. That is a two-stage sampling. The last one will replace in the that week will replace carbon unequal probability sampling of clusters. We'll first review some of the terms associated with cluster sampling. Observational unit is an object on which the survey measurement is taken and is often called element. Sampling unit is a unit that we actually apply samplings on. And if the sampling unit is equal to the element, then it is called element sampling. Otherwise, we may select a group of elements called clusters. And cluster sampling means that we select clusters. Sampling unit is cluster. So in this page, we list some examples of clusters for cluster sampling. In the usual household surveys, we may have a list of addresses but not list of the people. So the way we approach to people is through household, visiting household. So in this case, the sampling unit is household. Another popular example is the survey of students, where the sampling unit is school. So sampling is schools, something like that. So we no longer assume that sampling unit is element. Cluster sampling is actually quite popular, and there are two main reasons for doing cluster sampling. The first reason is that we wish to select element, but we cannot because we don't have a frame. So the no frame for elements, but frame for cluster is easy to obtain. And secondly, it's cost effective and convenient. And so usually if you select clusters, then the cost data collection increases with distance between the elements. So the closer, then the cheaper, something like that. And the second reason is probably more convenience. So we can, once we visit the household, we can actually ask questions to other members of the household. So that is the practical reason. Now let's introduce some notation for cluster sampling. So UI, script UI is index set of clusters in the population. Script small I means that i's cluster in, and the cluster mi is the number of element in cluster I, and yij is the measurement of y item y at the jth element in cluster I. So we have two levels. So the j level, j is the element, and I is cluster level. And so the total, the summation is double summation, because we have a summation over I and summation over j. So all the clusters and all the elements in the cluster, and over yij. And then this guy, we can call it ti. So that means the cluster total for cluster I. And then that is this cluster total is a summation of the cluster size times the cluster mean. right? So that is the cluster size, and then cluster mean. Mean of y, population mean of y in cluster I. Okay, and finally, the population size is the total number of elements. So that is capital N, and this capital N is not necessarily known. So usually Ni is known, but not capital N. Now we introduce additional notation in the sample part, sample level, from the cluster population UI. So UI, we select sample, right? So sample clusters, and then small ni is the number of sampled clusters, and then the sample is the index set of the elements in the sample. That is the union of the UIs. And so that the sample size is the number of sampled element is a summation of MIs in the sampled clusters. So even though Ni is fixed, because this is the number of sampled clusters is fixed, but total number of sampled elements is not necessarily fixed, because MIs are these MIs are different. Okay. So we'll consider the following sampling design in this week. So basically, we apply simple random sampling over clusters. So among the capital Ni, we select the small ni. So that's the sampling part. And then the measurement part, we observe every element in the selected clusters. So basically, we observe from cluster I in the sample. From cluster I, we observe Ti, and also we observe Mi, because we observed how many of elements are there, how many elements are there in cluster I. So we observe this one, Mi, and also Ti. Okay.